You know, we're pretty sure the universe had a beginning. A big, fiery, incredible bang. But the real question, the one that keeps cosmologists up at night, is how's it all going to end? Today, we're going to take a look at the possibilities. Think of this as your field guide to the end of everything.
So how does it end? I mean, this is a question people have been asking forever. But now we can actually start to piece together some real science-based answers. And let me tell you, the scenarios are wild. They range from a quiet, lonely fade out to some of the most unbelievably violent endings you can imagine. So let's get into it. Everything we think we know about the end really starts with this one massive discovery. It was a total game changer, and it even won a Nobel Prize. Astronomers found out that not only is the universe getting bigger, but the expansion is actually speeding up. It's hitting the gas. And that is the central mystery we need to solve to figure out our ultimate fate. All right, so here's our game plan. First, we'll look at what this runaway universe really means. Then, we'll meet the mysterious force behind it all and explore the, well, messy ways it could all get torn apart. After that, we'll dive into the classic cosmic showdown, freeze versus crunch. Then we'll get really weird with the idea of the universe's bubble bursting. And finally, we'll talk about why this final chapter is still very much up in the air. So this idea of an accelerating expansion, seriously, it was a total shock. For decades, everyone just assumed the big question was, will gravity be strong enough to stop the expansion and pull it all back in? But the evidence said, nope. Something out there is actively pushing everything apart, making it go faster and faster and faster. So what in the cosmos has that kind of power? What could possibly fight against the gravity of, well, everything, and win? Scientists have a name for this cosmic ghost, even if we don't totally get it yet. They call it dark energy. Okay, so what is this stuff? The key phrase here is negative pressure. Now, that sounds weird, I know. A simple way to think about it is that it acts like an anti-gravity. It's a property of space itself that creates a repulsive force. It doesn't pull things together, it shoves them apart. And it's everywhere, totally unlike anything we deal with in our day-to-day lives. Now, here is where it gets really interesting. It seems there might be different flavors of dark energy. On one hand, you've got your standard dark energy, a cosmological constant. It's steady, it's predictable, it causes a constant acceleration. But then there's this other thing, phantom energy. And trust me, it lives up to the name. This isn't constant. This is dark energy that gets stronger over time, leading to a runaway effect. And if this stuff is real, that's when the endings get truly spectacular. So what happens if this phantom energy is the real deal? Well, the universe isn't just heading for an expansion, it's heading for a complete and total catastrophic breakdown. The push of this phantom energy will eventually grow so powerful that it will just overwhelm every other force. We're talking gravity, electromagnetism, all of it. The result is something they call a rip. And this would be a step-by-step demolition of reality as we know it. It starts on the grandest scales. First, clusters of galaxies get pulled apart. Then, the force is strong enough to rip individual galaxies to shreds, sending stars flying. Then, solar systems are destroyed as planets are torn from their stars. And in the final, terrifying moments, the force becomes so strong it shreds atoms themselves and literally rips the fabric of space-time apart. That's the big rip. And of course, scientists couldn't just stop with one doomsday rip scenario. Oh no, they've come up with variations. You have the little rip, which is basically the same thing, but it takes forever to happen. And then there's my personal favorite, the little sibling of the big rip. They all end with everything being torn asunder, just on, different cosmic schedules. Okay, let's just take a deep breath and step back from all that ripping for a second. Before we discovered this whole acceleration thing, the debate was a lot simpler. It was basically a cosmic coin toss between two totally opposite endings. On one side of the coin, you have the big freeze. Some call it the heat death, which sounds pretty bleak. This is probably what happens with just standard dark energy. The universe keeps expanding, and eventually distant galaxies are moving away from us so fast their light can never reach us again. They just blink out of our sky. The universe will become this vast, dark, cold, and incredibly lonely place. But then, there's a huge twist. What if dark energy isn't pushing at all? What if it's actually pulling? This quote points to an incredible possibility. Some models suggest the energy of empty space might actually be negative, and if that's true, it changes the entire story.
Yeah, and negative constant means that the expansion we see is living on borrowed time. gravity would eventually win. It wouldn't just put on the brakes, it would throw the whole universe into reverse. Everything, all the galaxies, all the stars, would start rushing back together, faster and faster, until the entire cosmos collapsed back into an infinitely hot, infinitely dense point. The Big Bang, but backwards. The Big Crunch.
Okay, so we've been ripped, frozen, and crunched. What else could there be? Well, get ready because this last one might be the strangest of them all. This scenario has nothing to do with expansion. It has to do with the idea that the very fabric of our reality might be unstable. The idea is that our universe could exist in what physicists call a false vacuum. The analogy here is perfect. Imagine a ball resting in a little dip on the side of a hill. It seems stable, right? It's not rolling. But it's not at the very bottom of the hill, its true lowest energy state. The theory is that our universe could be just like that all, seemingly stable, but with the potential to drop to a lower, more stable state.
Now, if that theory is right, then at any moment, anywhere in the universe, a little patch of space could just randomly quantum tunnel to that more stable state. This would create a bubble of true vacuum, a bubble of a new reality with totally different laws of physics. And this bubble would expand outwards in every direction at the speed of light. We would never, ever see it coming. Everything it touched would just be erased, instantly rewritten by new physics.
So, wow. We have these absolutely mind-bending scenarios. Being torn apart, freezing to death, getting crushed, or just being blinked out of existence by a bubble. It is a lot to take in. And it's so important to remember that we are talking about ideas at the absolute bleeding edge of human knowledge. So how do we make sense of it all?
This chart really helps lay it all out. You've got the big rip, driven by that terrifying phantom energy that tears everything to shreds. The big freeze, the slow, quiet death from regular dark energy. The big crunch, if it turns out dark energy is negative and pulls everything back together. And then the ultimate wild card, vacuum decay, a random quantum fluke that just rewrites reality from scratch.
But wait, there's one more crucial twist. A potential get-out-of-jail-free card for the cosmos. You see, the most extreme endings, the rip, the crunch, they all result in something called a singularity, a point where our known laws of physics just break. But this quote shows us there's hope. Many physicists think that a full theory of quantum gravity, the holy grail of modern physics, might actually prevent these singularities from ever forming. The universe might just have a built-in safety mechanism.
So, in the end, it all comes down to this. Our universe's fate depends on the true nature of dark energy and the secrets of quantum gravity. These are forces and ideas we're just barely beginning to understand. So, will it be the rip, the freeze, the crunch, or the bubble? Or could some new physics we haven't even dreamed of yet save the day? For now, the final chapter in the story of the universe remains completely unwritten.